All right, 5 and 6. Find them. There they are. All right, so the x-axis on these graphs here. Use this feature. Nice straight line. All right, number 5, 2 over x minus 1 plus 2. So we have a few things occurring. We're going to go forward 1 unit, up 2 units. Dilation, a vertical dilation of 2. So again, our parent function is 1 over x, which looks like this. So we're going to go forward, up, and a dilation of 2. That vertical dilation, a stretch, it's kind of hard to see on these graphs, but you would have to plot a bunch of points, or if you do it on a calculator, you can tell the difference much more clearer. All right, and then parent function, let me just, one more thing, the asymptotes were there and there, y equal to 0, x equal to 0. These transformations are going to shift that. So if we go forward 1 unit, your vertical asymptote is now going to be right here at the line x equal to 1. If we go up 2 units, the horizontal asymptote, let's do that one, is going to be right there at the line y equal to 2. All right, so those are our asymptotes. There was no reflections, so our branches of this rational graph, they'll be in the same locations. One of them will be here, one of them will be here. We just need a few points to kind of determine, to get a more accurate picture of the graph. Domain real quick, you cannot divide by 0, so x cannot be equal to 1. If x is 1, you get 1 minus 1, which is 0, which is not good. So that's your domain, all x's except 1. Your range, you can tell from down here, the range will hit, the y values will hit everything except 2. So every y value except 2 is allowed. If you want interval notation, you go negative infinity to 2, union with 2 to positive infinity, parentheses around everything. All right, the asymptotes, we already wrote them down. X equal to 1 is the vertical asymptote. So that's your vertical asymptote. Y equal to 2 is your horizontal asymptote. Let's just pick a point or two to kind of help guide us. In the next section or two, we'll also need to plot the x-intercepts and the y-intercepts. So it would be the asymptotes, the intercepts, and any holes in the graph, and then any other points that you feel are necessary to draw your graph. All right, so 1 is where my vertical asymptote is, so let's pick a value after it. Let's pick a value before it and plug in. If we plug in 2, what do we get? 2 minus 1 plus 2 gives us 4. So at 2, we have a point at 4. Plug in numbers closer and closer to 1. And the y values get larger and larger and larger. So 1.01, 1.001. Plug those in, you need larger and larger y values. Plug in larger and larger x values, and the y value will get closer and closer and closer to 2, approaching it but never hitting it. So you'd get something like 2.1, 2.01, 2.0001, and so on and so on. All right, let's plug in 0. So 2 over 0 minus 1 plus 2, negative 2 plus 2, so that's 0. We got the x-intercept. That's pretty nice. So at, when x is 0, the graph is at 0. So that worked out nicely. So we found the x-intercept and the y-intercept, as it turns out. We plug in x values closer to 1. So 1 half, 0.7, 0.8, 0.9, 0.9999. As closer as you get closer, the y values are going to get smaller and smaller, going towards negative infinity, negative 100, negative 1,000, and so on. On the other side, all right, let's change colors so it stands out. As you pick x values that are smaller and smaller, negative 100, negative 1,000,000, and so on, the y values will approach our horizontal asymptote, y equal to 2. So the y values will approach 2 but never hit it. So 1.9, 1.99, and so on and so on. So there's number 5. We had some shifting. We have a dilation of 2, but again, it's kind of hard to tell the difference between the branches. We try to compare them graphically, unless you do a whole lot of points. I would recommend looking at it in a calculator to see the dilation effect on it. That's number 5. Alrighty, number 6. So the parent function of number 6 is 1 over x squared. And if you recall the graph of that, everything is positive because we're squaring whatever x value you plug in. The asymptotes were still y equal to 0, x equal to 0. So if we base it off of that, let's look at what we have here. Minus 2 is going to send it down. Plus 1 is going to send it left. Anything with the x is a horizontal transformation and having the opposite effect. 3 is a vertical dilation of 3. So it's going to make these grow faster. Okay. All right, as well as other slight changes on the graph. So given that, let's go ahead and shift our asymptotes. That's a good way to start these. We're going down 2 units. So let me think this out. My horizontal asymptote is now here at the line y equal to negative 2 due to that vertical translation. My vertical asymptote, we have to send it left 1 unit. So instead of being here, it's going to be here. So your graph will fit between those. That's the line x equal to negative 1. All right. Domain and range, we can tell that 2 different ways. Graphically, if we graph it, domain you cannot divide by 0. That occurs when x is negative 1. So x cannot be negative 1. So you can plug in anything except negative 1. Let's do some graphing and then we'll come back to the range. Asymptotes are there, so we have those equations. All right. Let's see what we got. Let's pick some points on either side of the vertical asymptote. So let's pick something. Let's pick 0. It's always nice to work with. And let's go. Let's go negative 3. All right. Plug it into the function. Plug in 0. Plus 1 is 1. Squared is 1. 3 divided by 1 is 3 minus 2. So we're going to get 1 right here. So we have that point. Plug in negative 3. Plus 1 is negative 2. Squared is positive 4. 3/4 minus 2. All right. Gives us a fraction. What's 3/4 take away 2? It's looking at negative 1.75. Let's go ahead and verify that. Take away 2. It's a good thing I'm verifying it. It appears I made a mistake. 1.25. Negative 1.25. All right. So 5/4 or negative 1.25. Either one works. I love fractions, but decimals sometimes are easier to work with when you're plotting. So 0, 1. There we go. We actually got the y-intercept, which always occurs when you plug in 0. So again, that's a key feature you want to look out for as we do more and more of these. -3, -1.25, so we're about right there. All right, let's go ahead and graph. Heck, let's go ahead and find the x-intercept. I'm going to set it equal to 0 and find the x-intercept. Because we're going to have one, given the shifting of this. In fact, we're going to have 2. So let me go ahead and do that real quick. Let's make some space. Let's clear some of this. Okay. Bear with me, equal to 0. So we're going to add 2 to both sides. Multiply by x plus 1 squared. We're looking at a quadratic. So let's see. So get through this. X squared plus 2x plus 1 minus 3. 2x squared plus 4x plus 2 minus 3. All right. So we set it equal to 0 and solve it. Those are the steps. Move everything to one side. It's a quadratic. If it factors, great. If not, quadratic formula will be the method to choose, or completing the square. All right. It's not going to factor nicely, but x will be, so you're going to have to do quadratic formula. You get 2 results. Those right there. So when x is those 2 values, so 0.2247, somewhere in there, and -2.2247, somewhere in there. So heck, we actually have everything we would actually require. Asymptotes, holes, there were none, and intercepts. Let's go ahead and graph this one and be done with it. As x gets closer and closer to -1, the y's blow up. As x gets larger and larger, the y's approach -2. On the other end, as x approaches -1 from the left, so here to here, the y's blow up as well. As x gets really small, -100, -1,000,000, it approaches the y as well. All right, so my range, very bottom to the top. So from the graph, you can tell the lowest it'll go is this -2 that it's approaching, but it'll never hit it. So -2 parentheses, it never hits it, up to infinity also with parentheses. Inequality, it will be y strictly greater than -2. Set notation, heck, might as well finish it off. Y such that y is greater than, strictly greater than -2. So there is number 6. We got everything we needed. Holes in the graph, there was none. Asymptotes, we got them. And our intercepts are x and y intercepts. So number 6 is complete.